на другій частині конференції і наш наступний спікер Грегорц Мазур. Вітаю.
Oh, it works.
Hello. So my name is Gregorc Mazur. Welcome to my presentation called Going Multiplatform. It's a Crash for Enemies and also the Instant Simulator Technical Postmortem. It's two last games that we put out, and I will tell you what challenges we had and how we fixed them. But first, by any chance, maybe someone already knows us? Is there anyone in the audience? One person, okay. It's a success already. So we are While Monarch from Warsaw, Poland. We are quite young because we started working together a year and a half ago. So yeah, we put out these two games. We work with some others, but I will only talk about those we already released, of course. Who am I? I'm one of the bosses and technical director at this company, While Monarch. Previously, I was working at Living Studios. Maybe you know the game This War of Mine, so I was the programmer there. It's so far the biggest game I did. Also did Sleepwalker's Journey, that's another game for this company. So after 4 years there, I decided to leave and start something on my own. So that's how While Monarch created. I'm also a lecturer at Warsaw Free School, where I teach game programming in Unity. I'm actually a musician. Here's my email and Twitter if you want to talk, contact, or whatever, feel free to write. I always like to talk with people. But going multi-platform, so this will be topic for today, these two games. It's Crash for Enemies in OSR, so these are the screenshots to show you the game of both games. So Crash for Enemies is a tiny RTS game. We wanted to bring all the experience and challenges from big RTS, but squeeze it to really short battles, because we as a player don't have time for long games anymore. So we wanted to have the same fun, but in the battles that last for 5 minutes, not for 5 hours. So that was our idea. So this is the screenshot on the left. And the other game, the latest one, OSR, the Instant Simulator, is the game that, the idea for the game came up on a game jam. It worked quite good, so we decided to make a full game out of it. 2 players build insults with the bits of the words that appear on the screen, but the insults are not with the vulgar words, but just absurd, funny things like, I don't know, your mother is your father. So you build something like that. So this is like a new genre, nobody, I think, did it before. There was some mechanic in Monkey Island, as we later found, but besides that, it's something new. So both games are totally different for players. One is RTS in a tiny one. The other one is the Instant Simulator, so something totally different. But from a production point of view, from our point of view as developers, they are really, really similar. So yeah, I will point by point tell you what problems we had and how we put those games and what was similar with these two games. So yeah, what was the same and what we did on both games? First of all, we decided to go, of course, multi-platform, and we did simultaneous launch on Steam, which is PC, Mac, Linux, so we have 3 platforms here. Then Google Play, and App Store, which was iOS and Mac. So for example, for Mac we had 2 different builds, one for App Store, one for Steam. The game is the same, but they have different libraries connected, right? One is for Steam, one is for App Store. Both games were done in Unity. Both games were done by almost the same team. Crash Enemies was a bigger game, so it was done in a longer time. It was 1 year, even more. OSR was done in 6 months. So, but the team was quite similar. Graphics for both games are pixel art, so it's also quite important. I'll tell you later why it's a problem, why it's a challenge. And we had really similar game modes. We had single-player campaign, we had the local multiplayer that allows 2 players to play on one device, and we had cross-platform online multiplayer. This is also important, so it was also the same challenge in both games to do this correctly and efficiently in a really small team. So the games are totally different, but from our side of view, they were quite similar. So I will not tell you how to make a game in Unity, because it's a topic for a totally different speech. I will tell you about the problems that we had because of going multi-platform and because of using Unity. Because Unity is not perfect, there are no engines that are perfect, so we had a lot of problems that we realized during the development that we are not expecting. So I will tell you about this. So if you are doing games in Unity, maybe you already know about these problems, or you will reach these problems later when you will do your games. Okay, so let's talk at first in general about going multi-platform, why it's a bad idea or why it's a good idea, and then how we did it. First of all, let's talk about why this is really bad idea. First of all, it's really long building and uploading to the platforms phase, because even if a game is small, when you go to 6 platforms like we did, or we even released also on GOG, so it gives us 3 more builds. So for OSER it was like 9 different builds. Every time when we want to update the game, we have to build 9 different versions of the game, test all of them, upload them to the store, pass the certification on Apple's, for example, on Apple Store. And it's a lot of work, especially in a small team, when you have 3 or 4 people, and for example, there's only one programmer that takes care of building. It's a lot of work. It's like a whole day of only building. So it's a really costful thing, right? It's a nightmare for quality assurance. It doesn't matter if you do this internally or externally, you still have to do these 6 different builds and send them to QA, and they have to test all of these. So it's a lot of work, even in a small game, because some features can work differently on different hardwares, on different systems, and we have to check all of this. There are far too many different screen resolutions, and it's really important with pixel art, because in not pixel art games it's easier to do this, but pixel art have to be done pixel perfect. So when you are going only for PCs, it's easy because you can assume that most of the computers will be HD, full HD, and I don't know, maybe some percent or not, but you have 2 typical aspect ratios and that's all. But when you go to mobiles, you have everything. You have every different aspect ratio, different resolutions, and you have to prepare your game that will look okay and work okay on every of these resolutions. Different input systems, right? So you have to design and build and code the input systems for touchpad, for touchscreen, for gamepad maybe, but also for keyboard and mouse. It also brings lots of problems, even in small games. Different hardware limitations. In small indie games, it's not that big problem anymore on PCs, because most of the games will just work everywhere, because hardware is strong. But on mobile, it's still a problem, especially with memory, especially on Apple devices. You have to squeeze your game into a really small chunk of memory, or the game will crash, right? So it's still a problem. It still limits us a lot. So we had this problem even with these 2 small games, and it took us some time to fix these problems, right? And the worst thing that I hate the most about going multi-platform is that fix for one platform can destroy other platform. Because you fix something that doesn't work on a phone, and later you realize that this fix broke something on a PC, for example, or the opposite. Or even on the same platform holder it can happen. We had this issue with, I think, Crash Enemies on Google. We wanted to release the game on the phones and Google TV. So both are Android, actually did the same build, because it works, because it's Android also. The difference is one uses gamepad and the other uses touch screen, but also you can support gamepad on Android phones. And we're talking with Google about featuring, and we have to pass all the requirements they have to be featured. And they had some requests for example, how it should work back button on a gamepad and on a phone. And when we fixed this to work on a phone to reach this requirement, we realized that it doesn't work on a gamepad correctly, because they have different requirements for working on an Android TV. So we changed this back, and we broke this time, we fixed the Google TV, we broke Android phones. So it was a lot of work, a lot of this kind of problems. So these are the good reasons to never go multi-platform. And after doing OSER, which was another game, which was the second game we did. We launched simultaneously on 6 platforms at the same time. And I thought, I will never do this again. Let's just build PCs, then a couple of months later let's go for mobiles, and so on. Just divide this work on some time. But when the game starts selling, I thought, maybe it was actually a good idea. First of all, bigger money, smaller risk, right? So if you will do okay on one platform, then if you went to 6 platforms, for example, maybe you will do really, really good, because every platform will earn some money, and when you sum everything up, it's a lot, so maybe it will be easier to make profit. And it worked like that, exactly. And it's also a smaller risk. When you will not do well on one platform, you have always other platforms. It sometimes happens that, for example, players don't like your game on mobile, but hey, it's great on PC, so I will play this on PC. So it's smaller risk. We have some kind of synergy between the platforms. When one platform is doing really good, then it always boosts sales on the other platforms. It always happens because people talk to each other. They say, "Hey, I find this cool game. Maybe you should check out." And they always try to find it on their platform, their own platform. So if the PC player talks to the mobile player, sorry, I have to. Can I go outside for a second? Okay. I'm sorry, I have a problem with my head. I'll just some fresh air, okay? Yeah. Sorry. So I stopped at Synergy. When one platform does really good, it always helps other platforms. Also, every marketing push helps all the platforms. We had this thing with YouTube, for example. When there was a big YouTuber who recorded a video that was very popular, it helped all the platforms. We had a marketing boost on sales boost on Steam, on mobiles, everywhere. Because, as I said earlier, players always try to buy the game on their platforms, their favorite platforms. So if they watch videos, they try to buy it on phones, on Steam. So it always helps. So it's easier to monetize every player interested in our game, right? Thanks to that. And also when you go multi-platform, it's always the case with the indie games that when you do only multiplayer, it will work only if you will have players, right? So you have to have this critical mass, critical number of the players that will make the online multiplayer live and work. So when you go with cross-platform multiplayer, online multiplayer, and you have many platforms, it's really easier to have this big number of players and make online multiplayer work all the time. So that's why going multi-platform is also good when you are going to do online multiplayer, and we did this with Crash Randoms and OSER, so it helped us a lot. Okay. So a couple of general thoughts on going multi-platforms. First of all, we seen that if you want to go multi-platform, we should think about this from the very beginning. So we should try to design our game and code from the beginning for all the platforms and to prepare for touchscreen, prepare for gamepad, for keyboard, and so on. And you should try to do your game once, right? So not to do the game on Steam and later try how to put it on mobile, how to change it, how to rewrite it maybe, because it will be a lot, you will lose time, and time is money, right? So it's not that profitable. So it's, if only you can, try to do your game once from the beginning for all the platforms that you plan in the future. So do your game once, but tweak platform-specific things. So you always have to make it work on every platform really good, because in other case players will tell you, hey, it's a really crappy port from a different platform, so you still have to tweak it. So do really good input system for mobile, spend a lot of time on tweaking gamepad and so on. And good code idea, we always try to divide the specific platform-specific things on the different scripts. different managers. So we have, for example, totally different code for gamepad, different code for keyboard, different code for example, when we have these leaderboards or social things that are connected to the platform, we try to divide it on the different managers. So we have some different code for Steam, different code for, I don't know, Android. And we always try to divide this code, because if it will all be connected, like, you know, cascade of ifs and elses or switches, it just gets worse and worse when you add next platforms and next platforms. So it's a good idea to just divide it on the different scripts. In Unity, you can just put different game objects and put the scripts on these objects. Especially in mobile, it's also important to test your game on every platform from the very beginning. We did this mistake with Crash Enemies, that we were not testing iOS from the beginning, and really far in the development, just before final tests, we realized that we don't have enough memory for the game. So as I said before, so if we will test it from the very beginning, like we did with Oser, for example, it will work better. And we can find the problems from the very beginning. It will save time and save a lot of nerves. On Android, you can still have problems with performance, so it's also good to test it from the very beginning on every target device to know the problems from that early as possible. Okay. So that was like a general ideas. Let's go with Unity, with specific things connected to Unity. So as I said, yeah, it's okay. Unity is great, like every good engine is great, but it's not enough. Every engine also has its own problems. So I will tell you about these problems we found and how we try to fix them. First of all, Unity version, and it's also the case with other engines. Newer versions are not 100% compatible with previous ones. They should be, and they guarantee they are, but they are not. We had some features that stopped working in the next versions, or just started to work differently, that broke our game. It's a problem, or they just sometimes doesn't remember about something, and some fixes in Unity in the next version break some features on one specific platform. So we found this and decided that we should freeze the version of the Unity like at least 2-3 months before launch and leave it, because okay, maybe this version of Unity will have some bugs, but at least we know these bugs and we can do workarounds. So when we will update the Unity, we can have some new bugs and we will forget about them, and it will be harder to find them. So yeah, the problem is new fixes will not be available from Unity. And it may cause problems with platform updates, because platforms are updated, like Apple Store is updated and Google Play is updated, and the previous Unity version can be a bit incompatible, so you have to fix this somehow. I'm sorry guys. But still it's safer, right? Especially if you're doing QA, external QA. It costs a lot of money. So when you are doing QA, after QA, never update Unity version, because you will have to do QA from the very beginning, and that's another cost. Okay. So as I said, both games were pixel art. The problems with pixel art is that it can be scaled only by integers, like by 2, by 3, by 4, not by 1.5, because it will break pixels. So this is the challenge, to support different screen resolutions. So we approach this topic a bit different in both games, but in both solutions we had to overdraw really a lot of assets. For example, for Crash Enemies we did much bigger backgrounds that we needed, and we just wrote the code that scaled the camera to find the best fitting for each screen. So sometimes it was scaled by 2, by 3, or by 4, to always fit the screen the best, but we still had the margin, so we always had to overdraw a lot of margins So in Crash Enemies we did like 4 parts and we just moving them. And for OSER we are just doing bigger backgrounds and it worked okay. So we have to remember from this again from the very beginning, like paint much bigger backgrounds and think about it. It also consumes more memory, so we have to be sure that we'll have this amount of memory, because pixel art still cannot be compressed, because it will again look really bad. So in most cases we don't compress pixel art textures on mobiles, so it's a problem of memory and so on. So multiplayer. There is a multiplayer engine in Unity, but it's not 100% reliable. So we decided to go with something different. There is something called Photon Engine. It's not only for Unity, it's meant for every engine, but it's also compatible with Unity. And it's great. It has really done great work, because it's really easy to integrate. When you have your game done, you can integrate like basics, like do a connections between the players in like 5 minutes. So this is the code that is enough to connect 2 players together and just starting sending messages. So it's super easy. And it's really reliable, because a lot of games use it, a lot of commercial games, a lot of big games. So it's really well tested. So we can trust this technology. Communication is easy. It's done via remote procedure calls or component synchronization. So they have some features, especially for Unity, that, for example, allows us to automatically synchronize components on game objects. And this is the thing that I was surprised that it really works exactly the same on every platform. When Unity doesn't behave exactly on the same platform, on every platform, then Photon Engine does. So it's really cool. So if you are going with multiplayer on a multiplayer with Unity, I would suggest to go with Photon Engine. It's really great. It's cheap. It's not free, but it's cheap. You pay some money for subscription, but it's not a big money. Okay. Configuration and balance. Unity has this, like every engine, every tool set for engine has this, interface where you can put some values. For example, when you have game object and components, you can write some values there, like configure every object in the game, which is an enemy or I don't know, some vehicle or something. But the problem is when you have a lot of data to configure. So for example, we had this case with OSER, when we had a lot of these words, and we had to configure how many points some connections between words give us. So we saw that there are hundreds and hundreds of these combinations, and it will be really hard or even impossible to put this in the engine, inside the Unity, right? In this inspector. So we were looking for some other options, and the best option we found was just to configure the data in a data sheet, for example in Google Sheets. It's an online tool for free, and somehow import this to the game. So there are plugins on Asset Store that let us do this, and we use this GTU for general sheets for reading configurations, and L2 for localization sheets, because it's specialized in doing localization sheets. So it's again, Unity doesn't have localization, so we can use this L2 to really easily import Google Sheets into the game, and it works like that. So it can help you a lot. So from this time, we do all the balancing in the game by sheets. We always import it from the sheet because it's just easier to write a lot of data in a sheet. We also can write some equations in a Google Sheet that will calculate some data for us, so it's easier than code it in Unity scripts. Okay, so another optimization. In Unity, when you want to use some resources, you mostly declare some values in the script and assign a resource from the project. And that's cool. But again, when you have a lot of resources, it's almost impossible, or it's a lot of work to handle this. So again, with Author we had these problems. We had a lot of characters, a lot of VO, and it was divided on different atoms. We had a lot of words. So instead of setting this everything in inspector, we automized it. So the game will read all the assets automatically. So there is a thing called resources. When you call the catalog in a project resources, you can access the resources by code, by name. It's the only way to do this in Unity, unfortunately, but you can use it. But you can also remember why it's not a good idea to use it for everything, because first of all the assets that are in a resources catalog goes to the build, so you have to keep it clean all the time, because Unity always tries to put to the build all the assets that are used. So in catalog resources, it assumes that all assets there will go to the build. So build can grow much bigger if you will just put there everything, and Unity will not filter it. And also resources have some limitation when it comes to the size of this part of resources. So you have to just keep it clean, right? When Unity does this automatically in every other place, in resources you have to keep it clean by yourself. And you can just pay attention to build log. I think not everybody knows that after building the game in Unity, you can access the build log. I found it like after a year of using Unity, because I didn't know, it's like a hidden knowledge. And you can see all the assets that are in the build and see how much space they take. So after doing every build, we always check this and see if it's correct, right? If there are not too many resources, because we have to keep builds small, especially for mobiles. Okay, so next automatization. Animations. We have this feature, like a mechanism called animator in Unity when you build a graph of animations. But again, you just click it in an editor. So if there are a lot of animations, a lot of repeating things, there's a lot of clicking. So in a special case like we had, which was pixel art graphics and animations were just sprite sheets, it's nonsense to click all those sheets and move them to animator, connect the animator graphs and so on, especially when you have a lot of characters. So it was pain in the ass, so we were again looking for a better solution. So we also wrote our own mechanism for this that was not using animator, but only we were switching the sprites. So it's super easy, and we just do it like old school, right? So we assumed that on a sprite sheet, in specific places there are specific animations. We wrote all the transitions in a code, so it's not that good, but it's better when you have a lot of characters, because you can later just put new sheet into the game when you put new character, and it will just work. You don't have to again click all those frames, connect, build animation files, connect in an animator and so on. So it was really easy. You can write it by your own, like in 5 hours maybe, it will work. And it's also better from usability point of view, because it's automat. So you don't have to work on this later, just put new sheets. And from a different point of view, it's better performance-wise, because animators in Unity does a lot of calculations in a background. It has some. Sorry, I have to stop once again. I'm sorry, something going on.
Maybe I need to take a seat.